This is the instruction that I help you to use the calculator Casio to do the calculation with Euler method to solve question D here. We have this problem about differential equation about the change in the population of wolf in an area. So this is the initial model, the first model, and here we have the second model. And lastly, this is the derivative of the second model, which describe the change of the population of wolves. So we can see that in this question, we have only one variable, which is x, and we do not have the second variable, which is y. Okay, the Euler method with a step size of 0.5 years and initial value x0, which is the number of wolves at the time. The starting time is 5 years since the beginning of the record. Okay, so here the initial number of wolves is 70, and with the step size 0.5 years, find an estimate for the size of wolf population when the time is 10 years. Give the answer correct to the nearest whole number and comment on your answer. Okay, in the calculator, of course, firstly we go to the menu and choose the menu 8 here. You can hit the number 8 to go to that quickly without the need of using the cursor. So hit number 8. Recursion 8 and here represent the time. So we will set the time. Condition error. Okay, the time here we enter an, which is initial time, and then add the step size, which is 0.5, 0.5. That is the time. Now the second thing, bn, is represent x. It's just a different symbol. We use bn in the calculator instead of x in the calculator. In the question, bn here is the number of wolf. So according to the formula in the formula sheet here, this one, the second row here, xn equal xn plus 1 equal xn plus h, which is the step size times the first function. Okay, so let's enter there bn, okay, and then plus the step size 0.5 and multiply with the first function, which is everything here. So let me put a bracket first, 0.0855, 0.0855, oops, sorry, 855, and then x in the function is the bn, okay, bn, multiply with ln, and ln of the ratio also 200 divided by x, which is bn, and then I close the bracket for the ln here, and then minus 0.03 again, x is bn, multiply with bn, and then I close the bracket. So this is the complete function f1, and then we multiply the function with the step size h here, which is 0.5. Okay, let's check the equation one more time. Here, xn equal xn plus 1 equal xn plus the step size times the function. So bn plus 1 equal bn plus the step size 0.5 times the function. The function is 0.0855, and then bn is the x here, the little x here, bn, and then time ln of 200 over bn, and then minus 0.03 times x, which is again bn. Do not forget to hit the execute button here to save the function, and then go to the setting, and we choose the initial condition. Start value is always 0. The number of steps is 12 because it takes 10 steps to go from 5 years to 10 years, because the step size is 5 years, 0.5 year. So we have 5 and then 5.5 and 6, 6.5, etc. So I chose 12 steps so that we get to more than 10 years, okay, from the starting time 5 years. The value 5 here is the starting time, and the value 70 here is the number of initial wolf, 70 wolf, okay. And then we exit and click the table here to see the result, table. So here at the step, the second column here, the time, we go to the time 10 year. This is the result. 89.428, and we round to 89 because number 4 is smaller than 5. So the answer is 89 whoops after 10 years. And if we continue, we see that it keep increasing, but the answer is 89. And so how do we comment on our result? The number of wolves